Ladies and gentlemen, it's our pleasure to invite Dr. T. Ramprabhu sir, and we are honored to have him share his insights with us. Before I do that, I request Dr. A. Chandrababu sir, coordinator of this FDP, to formally introduce Dr. T. Ramprabhu sir to the audience.
Yeah, good evening to all. It's a privilege to highlight the accomplishments of our resource persons for today's session. Dr. T. Ramprabhu is a distinguished scientist and engineer, currently serving as a scientist E and Joint Director at DRDO, Government of India. He holds a PhD in engineering design from IIT Madras and an ME in materials from IISc Bangalore. With over 15 years of research experience, Dr. Prabhu has established himself as a leading expert in his field, publishing over 70 research articles in international journals and garnering over 1,800 citations. He is a recipient of several prestigious awards, including the Lifetime Achievement Award for Metal 3D Printing, the Young Alumni Achiever Award from NIT Trichy, and the Award of Excellence from the Aeronautical Society of India. Dr. Prabhu has made significant contributions to various defense programs, including military aircraft, helicopter, aero engine, UAV, and missile programs. He has also authored several books and guided 18 PhD scholars. Thank you, Dr. Ram Prabhu, for being with us today. We are excitedly looking forward to your session. Thank you.
First of all, I thank Dr. Ramesh, principal of this institute, and Dr. Kiran and other good friends for inviting me to be inviting me for this FDP program. I do understand that I had a brief chat with Dr. Kiran. Who are the participants? That was the first question I asked him in the afternoon. Before I flashed the slides on metal additive manufacturing. So I was told like 100 participants are from electronics and about 20-25 physics and 20-25 mechanical. Since I belong to the mechanical field, so if I show that other 100 participants, I believe they will get bored. So what I think, probably for next 10 minutes, I'll just give an exposure on what is metal 3D printing. Okay. Followed by, I want you people to ask me the questions, what all doubts you have. Because what I believe, you guys are teachers, so you don't need to be taught on any subject. What I believe as an as an industry person, you guys need an exposure. That is what lagging in the academic sphere, which I thought I will give for next 1 hour. I'm sure the ideas, whatever I'm going to propose now, for next 10 minutes, you can explore in the internet to gather more information. And I'm not going to present the slides also, because the slides are too complex for all the other disciplines than the mechanical engineers. So there is only one slide I'm going to project it. That is at the maybe 10 minutes later. Before that, to address all the participants on electronics and communications and physics, and to some extent mechanical. First thing, what we have to understand, additive manufacturing is not the savior of manufacturing process. In other words, this is not the this is the only process which can replace all the manufacturing process. A kind of a thought you should remove from your mind. Okay, so I do understand that there are a lot of FDP on IoT, cyber security, additive manufacturing, so on. These are the emerging technology. That is the very reason the importance is given by the government. Okay, but emerging technology will not overcome all other present technologies. Okay, this emerging technology has its own space. For example, if you take it additive manufacturing, before I get into its advantages, I would say its limitation. This technology, you cannot do the mass production. Okay, so when you are unable to do the mass production, you cannot address the major industries like automobiles, transport sectors by using this 3D printing. But it gives a leverage of higher complex shape, which can be attained through metal 3D printing, because it's a tool-less process. My lead time to manufacture any part is very less. Any complex shape, lead time is very less. Any customization is possible. Then another very important thing, the advantage with the additive manufacturing is, whatever the kind of a design you can do it, you don't have any constraint on the manufacturing perspective. That is the biggest advantage additive manufacturing through to the industry community. But because of lack of mass production, first thing, Second is, if you look at this additive manufacturing, the ecosystem, the in the country, if you look at it, the kind of the industries which are operating in additive manufacturing are very, very less currently, and there are more scope for the resource. That's why, this emerging technology is given more attention. Whether can I effectively capitalize this manufacturing process for across the sectors? Okay. So in the process of capitalizing this technology, if you look at it, biomedical is the first industry which exploited the true potential of metal additive manufacturing. How? Any complex implants I can quickly print, and any customized shape based on the human's need, because each human have the different kind of a shape of the bones, densities, the kind of geometry what you have is not, it's unique, it's not same across all the human beings. So that's where additive manufacturing gives you edge. So people use the potential advantage of additive manufacturing to print the implants mainly. Another good thing in our country, ICMR, that is Indian Council for Medical Research, the regulations are such a way that they don't impose any limitations on 3D printing of the implants. Whereas in other industries, other countries like FA, if you look at it, US and other countries, where implant also has to be regulated by the regulating authority. Whereas in India, that regulation has not taken place. That's why biomedical industries tapping the potential of additive manufacturing. Then the second industry, aircraft industry. What is the advantage it's going to throw to the aircraft industry? Let's say I make a 10-15 parts. Okay. If I want to consolidate it as a single part, additive manufacturing will give you that advantage. So that's why, if you ask any aircraft engineers or the biomedical engineers, they always talk about additive manufacturing. Wherever the events you go, whoever the speakers, they belong to this community. Third potential sector is space. So wherever you have a very complex engine designs, especially the space engines, liquid propulsion engines, they have very complex shapes and made out of copper alloys. Okay. So, and a conventional engine have 1,000 parts assembled together, which involves a complex manufacturing like brazings, drilling, kind of a machinings, complex micron size level holes are made in that. So the process is so complex. The conventional alloy, the conventional engine build takes a long time, whereas additive manufacturing minimize the lead time when I adapt printing the engines through 3D printing. Okay. And keep in mind, in metals there are two ways you can 3D print it. One is either by using the laser beam, or another one is using the electron beam. And either use the powder as a raw material or wire as a raw material. That's why you always hear the buzzword of laser powder bed fusion, electron beam powder bed fusion, direct energy deposition. So these are the manufacturing keywords used in metal additive manufacturing. Okay. Now, what is there for electronics and communication? That's what we have to look into. Okay. So whatever I showed, everything, whatever talked so far, everything is about biomedical, aero, or space. Most of them are pointed towards structural application where the part fail by some kind of a stress or a temperature, and they don't serve any functional applications. When I mean functional, it's like, for example, piezoelectric material or smart material. If you take it, they have their other function. Like smart materials, example, you take shape memory alloy. So by changing its shape, it gives me another property. So that helps me in some applications like actuators or pipe couplings. And take an example of piezoelectric material. So where I can apply the mechanical signal and get the electrical energy conversion, or thermoelectric materials, wherein because of the temperature difference I generate the electricity. So likewise, materials are so far not printed by using either laser powder bed fusion or electron beam based one, or FDM, conventional polymer based 3D printing methodology, or selective stereolithography kind of a polymer based 3D printing. Okay. So now let's understand what are the applications for you in the electronics communication, where how you can jump into 3D printing, where you can contribute if you see in the research aspect or writing the proposal aspects. Looking at the whatever you use in the healthcare, like medical devices, wearable devices, or sensors like a pressure sensor or temperature sensor or strain sensor. These all comes under the flexible electronics. Okay, these are very well. It has a potential to be 3D printed. Okay. Second is in IoT devices. If you see device with integrated circuits or any interconnected devices can be easily 3D printed by using either FDM or laser based powder bed fusion. Then another important area where you have to focus, radio frequency antennas. Okay, antennas 3D printing is the another area where you can focus. Fourth will be energy storage devices, for example, battery materials, supercapacitors, solar cells. So there also we can use the 3D printing, either in the form of making the component or as a coating. Then printed circuit boards is another biggest area which is coming up in 3D printing. Okay, I will tell you what are the 3D printing process you can use it little later. Then another area where electronics engineers can focus is robotics. Robotics is the area where you have a lot of enclosures, grippers, some customized components will be there, which has an embedded electronic system. So how can I print these robots, that robotic parts like enclosure and grippers by using the 3D printing is the another domain where you can explore. Then MEMS devices, again physics and electronics, I don't differentiate them because electronics is a subsystem of physics. That's what I understand, because we study from the physics only the electronics comes. MEMS, mechanical electro system, micro electromechanical system, and photonic devices, which all comes under the purview of microelectronics. So this area also we can pitch the 3D printing. Then coming to the physics, so you do a lot of experiments, experimental apparatus, you make wherever you encounter the fixtures, vacuum chamber, optical benches, where you can employ the 3D printing and manufacture that customized design by using 3D printing. And coming to the quantum technology, so you may need some cryogenic equipments, qubit holders, these kind of quantum devices. There is a potential available for to 3D print those things. Then another area which is very interesting in avionics is EM shielding, electromagnetic shielding enclosures. This can be easily 3D printed. And physicists, they work on lenses, diffraction grating, wavegates, a lot of design components for the laser experiments, detectors, accelerators, space instrumentations. These all can be very well 3D printed in the ground as well as in the space, especially in the microgravity conditions. So these area you can write a proposals. So these are the applications you should note down and pitch the project proposals to achieve this the applications through the 3D printing. So now I have told you the applications. Now let's look at it. What are the materials comes under the purview of this electronics, physics, and mechanical? If you see, what do you people generally use in your electronic devices? Any kind of devices, whatever I so far I spoken. Conductive materials typically use copper, to some extent silver, and wherever the nanoparticles inclusions are there, like copper nanoparticle, gold nanoparticle, Ag, that is silver nanoparticles, and the conductive material like carbon black, CNTs, graphenes. These all can be used as a constituent in any material, okay, any alloy system as a constituent, either in the polymer or the metal matrix or the polymer matrix or the ceramic matrix, and you can develop a application oriented the products used for the electronics. And coming to the non-conductive materials, what you can work as an electronics person, all your printed circuit board substrate, if you see, they are typically a non-conductive one. Like people generally use ABS polymer, polylactic acid polymer, nylon. These are easily 3D printable because any thermoplastics are pretty 3D printable, not thermosets. But there are some work happening on epoxy kind of a thermosets and elastomeric material also. People are trying to 3D print it so that the flexible, the boards will be more flexible. And coming to the semiconductor area, if you look at it, the country recently 2 years ago we set up we released the policy by the government of India, bring the semiconductor fabs in the country in association with the Intel. So there is a first investment happened in Gujarat, and there's a huge mission, huge work happening by the scientific advisor team and to the Prime Minister in the country, wherein they are going to bring the semiconductor mission in the country in a couple of months down the line. Now, in the semiconductor, materials area, what all things you can do? Anything of metal oxides, doped silicon, you can think of how to 3D print those things. So these are the avenues available wherein you can pick this material, connect with the applications, whatever I told, and you can go for the the work or the research proposals which will be useful for the country's development, I would say. And I don't know how many of you know about PDOT, that is poly 3,4 ethylene oxyofin. So this is another semiconductor material used typically in the electronics device makings. And coming to the dielectric materials, anything of ceramic and polymer based composites gives the dielectric properties. For example, barium titanate, titanium oxide, lead zirconate, calcium titanate, magnesium titanate. Anything of the titanates typically show the property of dielectric as well as piezoelectric. And some of the exclusive piezoelectric material like potassium sodium niobate or lithium niobium oxide, zinc oxides. So if you look at it, this oxide kind of a ceramics are typically show the properties of piezoelectrics. So how to 3D print that and link with the applications, you have to look into that. And there are recently works happening on ferromagnetic materials. For example, ferromagnetic filters are added into the insulating materials in the composites and make them as a stealth composites. So these also you can focus. So now material, applications. Now you also you must know what are the processes are available, especially in the electronics domain. One is inkjet printing is one method wherein you can make the printer circuit boards and sensors and so on. The second will be aerogel jet printing. Why I'm mentioning these manufacturing processes? Because you have to have a material manufacturing process and applications. When you combine all the three only, you can target the specific applications. So this aerogel jet printing typically used for making the wearable devices and flexible circuits. Then most of the speakers would have spoken about fused deposition modeling. Okay, where you have a filaments, they will embed with some kind of a conductive polymers like a carbon nanotubes or anything of the carbon sort like graphene or metal particles. Okay, so this will help to make a simple circuits and conductive tracks. So this is the third method: inkjet printing, aerogel jet printing, fused deposition model. Then stereolithography, very famous process where people use the photopolymer and UV lights. So UV light is shine on your photopolymer and cure the resin, make it non-conductive parts, mainly for the electronics applications or device applications. Then like inkjet printing, you can also use the direct ink printing to make the multi-material structures. It's called the multi-material printing. So one layer will be of one material, next layer will be of some other material. So where if it is used, if you look at it, wherever you have a radio frequency antenna and embedded electronics, people go for this direct ink printing. Lastly, anything of the metal sorts which are used in the antennas and radio frequency components, people go for selective laser sintering or selective laser melting. So these are the opportunities available for you in the electronics and physics domain. Okay. In addition, if you look at the machine, I talked about laser and I talked about electron beam, right? So physics who are sitting over there, they are good at laser. Now you know very well about laser. Okay, when you focus the laser on metal, what happens? It reflects. Unfortunately, aluminum, copper kind of a metals gets huge energy reflected rather than get absorbed. In 3D printing, the idea is you throw the laser on the metal powder, laser get absorbed, it melts the your powder and start solidifying. If it gets reflected, all your laser energy is wasted. Okay, either you should go for the higher power laser or you should change your raw material. Now there is a huge need in the country where laser head development for additive manufacturing. So physics people can work on how I can go out of CO2 laser or neodymium laser to some other better laser, so that I can make the low cost laser with the high performance for metal 3D printing. So it is, you will come in the ambit of printer manufacturing. So even in the metal 3D printing machine manufacturing domain also you have a great say, especially in the laser head designs. The kind of a laser what to be used, the kind of instrument what we use it. Okay. And for the electronics people, there are a lot of sensors are put in the 3D printing machine. For example, they will put the optical sensor to capture the images of what's happening during the printing. They put some pyrometers to capture the thermal environment, temperature environment in the melt pole. So when you gather this, one is a sensor design, second is get this data and go for the machine learning. Okay, and optimize the process and also use it for preventive failures. Any failure which will be coming in future will be easily identified by the past, tracking the past data. So that's where you can use the machine learning. So where electronics people can definitely support. So if you look at as a globally, you have a say on materials, you have say on the applications, you have even say on the 3D printing machine, which has a laser, which has a sensor, which has a data generation inside, which can be machine learned. So these areas you have to pitch your project proposal to the government so that you can secure the funding. Okay. Now coming to the industry perspective for the mechanical engineer, I want to show only one slide. Why this manufacturing process is not adapted into the industry in a rapid pace. If you see, this process has come 15-20 years ago. Last 5 years, people have been speaking a lot about 3D printing, but how many industries are there in the country? If you look at it, it's hardly in single digit or double digit. And why it has not penetrated into the industry? If you look at it carefully, any layman can say, sir, cost is very high. How do I adapt this? Okay, any economy in the country depends on the how much wealth you generate. Wealth is again equated to the kind of a revenue generations. So any industry, if you go, they look for the high profit margin with the best performance. Just because the technology word is very soothing to my ears, the industry will not adapt. We academicians may feel very much excited about something new words like IoT, cyber security, and 3D printing and all. But when you come to the industry, everything is about cost. So what I understand, having put some 10 years experience in the field of 3D printing across in the country, where I primarily focus on aircraft parts manufacturing. I closely work with the armed forces, Indian Armed Force, to some extent to HAL and some private companies. What I understand is designers are very reluctant to adopt this technology because of the cost. But having said that, because cost is why I cannot just ignore it, because there are some certain advantages this process gives over the existing conventional process. So how do I leverage this, bringing down the cost, tapping the best potential from this manufacturing process? There are some avenues. One is, if you look at the 3D printing, all are done at the inert gas atmosphere, argon atmosphere. Is there any way can I replace the argon with low cost gases like nitrogen gas argon nitrogen ratio mixture, so that my cost will come down. Look at the research articles in the elsewhere to all the places, all the publishers. You will find tons and tons of paper on metal 3D printing or polymer 3D printing or ceramic 3D printing. Like, so I would say about 10 lakhs papers are there. You go and search how many papers are there useful for the industry. Hardly it will be 1%. That 1% also, if you look at it as a cost reduction point of view, it will be 0.0005% only papers are very useful. What it shows, the entire ecosystem of the academics are not actually tuned to the industry needs. We all waste our time by just paper publications, pattern publications, and glorifying the technology without understanding the technology's potential, and we are not actually exploiting the potential of the technology for our needs. So one suggestion I will tell to all the mechanical engineers, to some extent other engineers also who are sitting over there, please focus on channelize your energy wherein how you can reduce the cost of the product, okay, by tweaking the manufacturing process. So one way is what I said is change the inert gas to the nitrogen gas, like argon gas to the nitrogen gas. Look at the properties where all I can adopt nitrogen. As an academician, it is your responsibility to tell the industry these are the materials you can 3D print by using the nitrogen. Okay, let's say second is like I use a raw material, which is a powder. I print the part. Let's say 50 kg powder I dose into the hooper and I print it a 10 kg part. Remaining 40 kg currently they are wasting. Okay, which are left over in the build. Can I reuse it? If I have to reuse it, how many times I'm allowed to reuse it? Okay, and what method to be reused? Say I can just directly collect only reused powder and refill it, or I can mix it with the virgin powder, or I can just load it on top of the virgin powder. There are three methods are available, but which method is good, no one knows. And look at the research literature of last 10 years. Now, no information on, not much information on reuse of the powders and its effect. Moment that 40 kg which is left in the build as a reused powder, if I reuse it, then my cost will significantly come down. It's not only help me in cost reduction, it also help me in the environmental pollution reduction, especially the waste disposal problem completely eliminate. It's a kind of circular economy. Now again, there are some particles which will not powders which will not fit for reuse. Let's say that 40 kg 30 kgs may go for reuse, another 10 kg may not be fit for reuse. I cannot again dispose it. There is another route. The route is remelt it, make it as a fresh powder. So what I'm essentially trying to tell, nothing should be wasted, especially the raw material. Either remelt it or make it a new powder, or reuse it to build a part. Okay, this is some way of reducing the cost, where huge research is needed in the country. No focus is given by the academicians, which can be addressed by the academicians, because you are the guys who are responsible to work on the tier level problem less than 3, and you are the person who have a patience, you have a clear technical thoughts compared to the industry, and clear vision and strategy to take up any small problem and work. Whereas if you go to the industry, they don't have resources or the cost to do this exercise. So it is I would say it is your duty to do for the industry rather than just the sake of doing the research work in the academic institutions. Second is one of the mistake. I wouldn't say mistake. It is a kind of a evolutionary problem. Okay, in the additive manufacturing is conventionally this so and so material is there. I will 3D print the same thing. Okay, but if you put the Tamil Nadu fellow to the Greenland, he will not adapt to that climate. Okay, the similar parallel can be drawn here also. The things which goes very well at traditional may not go well in the 3D printing ambience, and vice versa. So now that's why I said it's evolutionary problem. When the researchers started researching, they wanted to mimic the existing one to see that whether I have a edge or not. But in the process, they burned their finger by feeling that the properties are not better than the conventional process, especially the wrought process, like a forged process or extrusion. But there is a new school of thought emerged over the period. There is an evolutionary mistake people have understood, scientists have understood, but they have also found a solution. The solution is very simple. Can I customize the alloy design for additive manufacturing? For example, physics people who are sitting over here, they can think of using your DFT and to some extent atomic simulation to evolve the new composition which is fit for additive manufacturing. Okay, and in this direction, there are good scientists who are from Germany have worked and come up with a acronym called RAM, reactive additive manufacturing. I mean, powders will be in the elemental form, but when you start printing it means like when you take it to the liquid state, it reacts and form certain kind of a precipitates, which will increase the strength of the material. If I put it very simply, okay. So that's where you have to focus, physicist, to complement or support your peer mates from the mechanical or the electronics. Can you evolve new composition, chemical composition for the metal additive manufacturing? This is a huge scope for you. There are less number of papers are available. Very few works have been done on this area. Huge scope for all of you to work on this area. Third will be for the mechanical people, how I can make it as a high volume production. This process, like if I have to do the castings, I just make 100 molds at one stretch. I start keep pouring, so I'll get 100 components in a click of 1 hour. But whereas 3D printing, one machine can produce one part or few parts in the build at a time. So I need to have multiple machines. When I go for the multiple machines, the biggest problem with the multiple machine, capital investment. Okay. So capital investment is huge, unlike other traditional manufacturing process. Okay. So is there any way out? Is there any way out? You have to look into that. Then, very important, what is the advantage or the edge this manufacturing process gives? Let's say traditionally I make a gear, or I make a printed circuit board, I make an antenna. Just mimicking same thing in 3D printing is not a charm. Okay, the charm comes, I am going to exploit the advantage of 3D printing. Can I make something very complex shape which is not feasible in traditional design? That complex shape or the structure is going to give me some advantages. For example, I would say you take a lattice structure. Probably the physics people and mechanical can understand. This lattice structure is very good for crash worthiness. Okay, and some structures kind of a design gives a negative Poisson ratio. So these are some of the advantages you can get by employing the geometry which is not traditionally feasible. So that's where you have to put your thoughts or your engineering skill or the technology skill to tell people, guys, this kind of a configuration, geometry, if I 3D print it, this extra advantage I get, which I don't get it in traditional space. So design for additive manufacturing is another area where you have to focus. Lastly, if industry has to adopt this technology, the designer should have awareness, not the academicians or the manufacturer. Unless any designer knows about this technology, he will never choose. So any FDP, any conference, any seminar you organize, make sure that some speakers are from the designer should be there. Whether they talk in 3D printing or not, at least let them tell what is their design philosophy, which way they design, what are the lacuna they have it. Okay, or you invite them as a participants also. Okay, the problem it lies in the country. You academicians stay in one island, industry stay in another island, R&D people stay in another island. All of them are not connected. But if you look at very corely, academicians are expected to work in the problem statement of TRL level 1 to 3. These 1 to 3, technology, whatever you discover or invent, is taken up for the prototype validation by the R&D people like CSER labs. Typically, they will bring the technology in a scale from the lab scale to the prototype scale. Then this industry will adopt the prototype scale and commercialize it. So this is the path of any research leading to the fruitification. But unfortunately, you do 1 to 3, which is not known to the CSIR lab. CSIR does something which is not known to the industry. So there is no connections. So always make sure that all the stakeholders are there in any kind of a discussions or the conferences or the meetings or seminars. Unless you don't connect all these dots, whatever the work we do, it will stay in paper only. The so-called the research paper, which is of no use to the country, but so much money is pumped on it. In fact, most of you know, recently one nation, one subscription has come to minimize the expenditure on the journals. The future, if you look at it, all of you will be going to have a next year all the government aided colleges. Very next year all the private colleges also will be included in one nation, one subscription, wherein you will have a high complete access to the quality journals in another next year, 2 years down the line. Okay, but what is your responsibility is publish or work in an area which is useful to the country, not just because your faculty has done some research on some area, you are doing the extension of that, or you have done PhD in that area. Unless you don't extend that work into to the commercialization or the business making case study, there is no use of your research. Second is which I always tell to all the academicians, you guys need the exposure. You guys don't need a teaching. Okay, make sure that you attend the very high quality conferences and industry expo to have a exposure on the advanced technology, to have exposure on what the industry practices. So these two you should always you should always pursue. That's what I believe. Okay. Then only we can build a strong nation. Unless the root, which is in a tree, the root is very important, or the foundation in a house, you guys are the foundation for the country, because you are creating the engineers, and you are the one who are seeding any discovery or the innovation. It is not the industry. Look at all Nobel laureates. They are not industry people. All of them are academicians. And if you look at the developed country like US or the UK or German, every company invests to the academicians to do the develop a technology. Then this technology will be taken up by the company for the commercialization. But unfortunately, the link is missed in the country. You academicians who are staying in the top, as well as in the industry, they should come forward and make this kind of ecosystem in the country. Then only we can build a strong nation. Okay, and exposure is the one what I believe you are lagging, especially not only in the technology, especially on the industry front. Unless you don't have a good exposure, your students will not learn what is they are supposed to learn. Okay, and always look into the a perspective of how to capitalize any technology, or how to invent a technology which has a capitalization. So that is a thought process you should have. With this, I think I spoke around 40 minutes. Next 20 minutes we can have a question answer, I believe. In case you feel that you don't have any other questions, the last 10 minutes I'll take some area which may be useful to you.
Good evening, sir.
Yeah, good evening.
So this is Karthikeyan. I have a question on the additive manufacturing, sir.
Please.
I am from mechanical department.
Mm-hmm.
My question is, nowadays the recent research is focused on sustainable materials, which
Right.
promotes the circular economy.
Right.
And my question is, other than the future deposition modeling FDM, can we use any other approach in additive manufacturing like stereolithography or SLS to develop low strength materials which we use in our daily life, like low strength materials like food packaging or even the motherboards of electronics, where
Right.
the lesser strength is.
Yes. See, look at this way only. What actually in what is 3D printing? If you see, it is an evolution from the existing process. It's not something came from the moon. See, what we are doing is here we use automation. Especially the automation will help you to get the more degree of freedom to get a complex shape. Okay. Second is either I use melting, or I use UV light, or either I use a UV light, or I use a heat, I use the pressure. These are the three medium I use it to consolidate the material. Now, look at your sustainable material, whatever you pitch in, either biodegradable polymer or to any kind of a sustainable material. If it is a metal, you go for the melting. If it is a polymer, you go for the UV light or to some extent heat. If it is a ceramic, again, ceramics are not melted, they are glued. Okay, by using the polymer, later it is sintered. Solid state sintering is done. This is the basic idea for you, basic framework for you. You take it any application, flexible. You talk about flexible, the electronic circuit board. Let me know the material. I will tell you what manufacturing process you can use it.
Sir, actually, I'm using biodegradable polymer like polylactic acid, in which biochar is dispersed, which is having good carbon content.
Right. So now here, what you have to do is you have to first make the filament. Filament infused with whatever the particles you said with your polylactic acid. Once a filament is made, you go for FDM, fused deposition modeling. That is the easiest way for you to get the your geometry.
So other than the FDM, can't I go for stereolithography or selective laser sintering?
Yeah.
And I tried this stereolithography, sir, but for polylactic acid, it's not possible.
Yeah.
Because of its less viscosity.
Yeah. If you wanted to go for a stereolithography, you need to have a UV curable polymers. Your polylactic acid is not a UV curable polymers, so you cannot go for stereolithography. Similarly, coming for the melting, polymers are not melted. They are softened and deposited. So if you have metals, you can go for the laser border bud fusion or the direct energy deposition kind of a melting process.
Yes, sir.
Yeah.
And can I use it as a blend, sir? Polylactic acid is not effective. Can I use it as a blending with some UV light material like epoxy?
See, epoxy is a thermoset. Okay, thermosets. The
Yes,
problem
sir.
with thermosets.
Recent times we are getting epoxy also UV light epoxy, sir, and I tried it in my college itself. We can use stereolithography using, we have any cubic devices there, sir.
Okay.
Current days we are even for thermoset also, especially for epoxy, we are getting UV light material where we can use stereolithography.
But logically,
can I blend this?
Any chemist, logically, if you go to any chemist, they will say thermoset. If you take it to the higher temperature, it will fuse. It doesn't melt. Okay.
Yes, sir.
Cross-link has happened.
Yes, sir. Thermoplastics.
Yeah. So thermosets are typically not printable. But I don't know how you got it.
This is.
You claim it, you got it, but I don't know. Technically speaking, I am doubtful about it.
Okay. Sir.
Yeah.
So thank you very much, sir.
Yeah. Your question can be in 3D printing or any area where if I have exposure, I will be able to answer. So you need not restrict questions to only 3D printing.
Okay, sir. Thank you very much, sir.
Yeah. If you really want to be a good researcher, unless you don't involve in dialogue, unless you think and have questions, you will never improve. So please bear in mind when you're writing any research proposals, your focus should be on any specific process or anything on the emerging technologies. So if you wanted to know about emerging technology, please go to the funding body websites plus scientific advisor to Prime Minister. Okay, there is a PSA to Prime Minister. They make the roadmap for the country's R&D expenditure. Okay, so go to the website and look at it. The problem statements are the research domains where country really wants you guys to work. So those area you just figure out and start working. Don't work in your comfort zone. So it is like a customer and a supplier relationship. What customer wants, if you give, you will get an order. Similar way, your customer is your government funding bodies. What they want you to serve, what you know, if you try to serve, they will not accept it. So that is a point I just wanted to pitch it. And there are a lot of calls going to come in through Anusandhan National Research Foundation. So I want all the audience who are sitting here, please go through ANRF. Okay, there are some funding modes. Recently, 5 calls have been announced, and future all these funding bodies comes under the ANRF. So funding modes, funding amounts will be distributed to all the funding body through ANRF. So you should be well versed with the ANRF, Anusandhan National Research Foundation. Okay, this body is headed by Prime Minister, and there are a lot of members in that. So, and they not only fund engineering and science, they also fund for arts, humanities, entrepreneurship, and so on. And what country wants? Multidisciplinary projects and multi-institutional collaborations. Okay, so please that you have it in your mind when you are pitching any project proposal to the funding body. So don't write as a standalone department. Collaborate with the other department and other institutions with the 2 or 3 co-PAs, start pitching the project proposals. Okay, that's one point I would emphasize to all the faculties who are sitting over there. Second is, as I said earlier, specific targeted applications are the need of the hour, not automobile or aerospace or biomedical. If you say aerospace, whether it's aircraft or engine, again you have to final narrow down. Let's say you narrow down to engine. In the engine there are different parts, what you are talking about it, whether blades or disc or compressor or turbine. So you have to narrow down to the very specific part, and you should address, and all the project problem statements should have a benchmark. Whatever the output you are going to generate through your research, either you should show it is superior or inferior to the existing. If you show superior, it will be taken up further. If you show inferior, others will not work on the same area. So that is what your research should do. That is the justice you do to the research community. So this is this point I will emphasize to all. I don't know about trusty areas you guys are exposed or not. Try to have a trust area awareness workshop rather than on any specific domain. Fourth, recently all these funding bodies are asking letter of support from the experts. Experts may be from Institute of Eminence, okay, or experts may be from industries or CSIR lab or DRDO ISRO kind of a people. The reason why they are asking this letter of support, you can draw the parallel with if you're going for a PhD postdoc abroad, how you get the letter of recommendation from your faculty. So it means that your faculty gives some recommendation. Similarly, when your proposal goes for the reviewer will see, okay, this so and so guy has given the letter of support. It means that this work has gone through some kind of a discussion or the review by the expert in the field. So that gives the confidence for the reviewer to accept your proposal and take it forward to the next level. And the third myth what everyone has in their mind is only IIT and NITs are funded, we are not getting. So to break the myth, I can give one example, recent example, where I contributed to one of the South College. It's a college in Tirunelveli, PSN College of Engineering. Okay, so one fine day they called me and they said, sir, we just wanted to pitch in, but we don't have a facility. And what are the project proposals? Last 5 years we have submitted, not even a single proposal has gone through for the next level. Can you just suggest us where we are going wrong? So I undertook a visit there and I just understood. Then I said, so the problem lies on the area what funding body needed. So that's what I was telling. So I told them they wanted to pitch the problem statement to the Aero Board, Aeronautical Research Development Board, ARDB. Then I said, don't work on 3D printing, don't work on emerging technology. What aircraft wants you work? See, currently we have an aircraft which is not stealth. Okay, it means like radar can easily capture the signal of the incoming aircraft. So the radar signatures are the current aircraft what we have gives a good amount of radar signature, so the enemy can easily detect me. If I make my aircraft stealth, I cannot be detected by the enemy aircraft. So this is what the need of the hour for the 5.5 or 6th generation aircraft in the country program. Then I told, so you make the stealth related, project proposals. Then these guys asked, sir, what you propose? Then I said, see, stealth can be made either you make the structure material stealth or give the coating on the structure. Third is you make a geometry such a way that the radar rays get reflected among themselves and get dampened out. So third is very difficult for them because it involves the design. People don't easily accept it. The first two are easy, either make the material or make the coating. They opted the material. I just told them, see this, just go and read about what is stealth materials. They quickly read and came in a week. They said, sir, I have to put some conductive material into this composite so that it will become a stealth. That's all. Then the project was proposed, and last week they called me and said, they got a next level call. This was the first milestone for them or the achievement for them, wherein they got an opportunity to present the proposals for the question answer. If they like the results are not has not come yet, but they said that they did well, and it is. I'm expecting if they had done well, probably the project gets sanctioned. And this college, I said, like most of you may not know, it is in the down south, and it's not that prominent college. When the not prominent college are able to, pitch the problem, go to the funding body, why not you people? It's all about your exposure and take up the problem statement what is needed by the funding body. That's where it's a lacuna. So the complaint of prejudice against us, IITs and NITs is no longer valid. So that's what the last their attempt shows are the proofs. So this is the point I just wanted to tell all the audience. It's not that you are not funded because other superiors are taken over your things. It is because of your inferiority complex and the not right problem you are selected is the reason for it. Okay. So this I want all the audience to know so that you will be knowing what problem statement to be taken so that it will lead to the success of sanctioning the projects. So we have another 4 minutes. Any questions I'll address. Otherwise, we can.
Sir, we have one participant with a question, sir.
Yeah. Anyone. I'm happy. I mean, we can extend up to 8 because Ravi Shankar has called me. He will join at 8 only. So I'm okay to.
Thank you very much, sir. So nowadays, what are the main advanced, I think, funding projects for mechanical engineering, especially, sir?
Okay. See, I would suggest you work on digital twin technology is the one area. Okay. Because a lot of funding has been given in 3D printing area. Focus next will be on how to enable digital manufacturing. So one is digital twin technology. Second is, how to enable the industry, connect them and sync with the cloud. So how to enable the cloud computing IoT to the industry, like a digital twin technology. Third area will be how to prepare the smart contract by using the blockchain technology in the industry. So these are the area if you focus for the mechanical engineers. See, what are the words I'm telling? I know that you don't have any exposure because it is more of computer science and electronic based, but they are only going to shape on our mechanical field in coming days. So more digitalizations are expected. So those areas where the TRL levels are less than 3, you need to address it.
Thank you very much, sir.
Yeah.
Sir, the metal additive manufacturing is for only especially for aerospace alloys or any other industrial manufacturing?
So one is the biomedical industry where they use the implants made out of titanium alloys, and dental implants made out of cobalt chromium molybdenum alloy, and oil and gas industry, all the stainless steels are used actually. Okay, so other than aero, space also, if you look at it, copper based metals are printed for the space applications. And in the field of avionics, so wherever thermal sink material needed, thermal management material is needed, those are also 3D printed currently. In fact, I myself, certified in the aircraft sector about 180 parts which are flying in our country fleet before you people started researching on it. Actually,
Okay,
so
sir.
this is the whole landscape of metal 3D printing in the country.
Yes. Thank you very much, sir. Thank you very much, sir.
Yeah.
Sir, good evening, sir.
Good evening.
Sir, for defense applications, what type of composite materials we can use, sir? Whether polymer matrix composites or ceramic matrix composites or metal matrix composite? Which one is suitable, sir?
Right. So you have to see like this only. If I go for the aircraft airframe structure, so my objective is lightweight. I should have good fatigue strength. So to fulfill that, people go for carbon fiber reinforced plastic. That is a polymer matrix composites. Okay.
Okay. Yes,
And
sir.
the second area is engine. Okay, where the temperature is very high. Wherever the temperature is very high, you have two choices: either superalloy or ceramic. Currently, superalloys are established, well established. So people use superalloys, and there are some, advanced companies like Rolls-Royce and GE kind of a engine manufacturer are exploring ceramic matrix composites for the fag end of afterburner. Okay, not the entire engine. So because the problem with the ceramic is getting the densification close to 100% is difficult. Second is the ductility issue. Any crack comes, it leads to the catastrophic failure. So to put it very simply, you have a glass, you just put it on the floor, it will break into pieces. Okay, but the same glass you put it in the tensile testing machine and try to deform it through your tensile machine, your tensile machine will break because the load cell will not be sufficient enough. So that's a issue with the ceramic, but people are trying to work out with adding some metals constituent inside, make it as a ceramic matrix composite so that the toughness and ductilities are improved. Okay.
Okay, sir. Thank you. Thank you very much, sir.
Yeah. I'm sorry I didn't show you all the slides because if I show you, everyone will not understand anything because it's more of a core technical. If I get into that technical, see, I just flick through the slides, you will understand. This will be like a Greek and Latin for all the EC and physics. And I know the 130 out of 160, all of them are, either physics or EC. So that's the reason I didn't run the slides.
Dr. Ram Prabhu sir, your session is highly informative, and the way you have encouraged the participants to do the research in the emerging research domains is really admirable, sir. And one more thing, what you have suggested is encouraging the participation of awareness workshops for the faculty in the thrust areas is need of the hour for those who are interested in the research. And also for breaking the myths related to the funding related to the private institutions which are not on par with IITs and NITs. That is really helpful for most of the faculty who have joined this particular FDP, sir. Thank you, sir. Thank you once again for joining us and sharing your valuable insights.
Thank you. We will meet in the next occasion, Dr. Grant. Thank you.
Thank you.
Thank you, sir. You are welcome, sir.